Okay, welcome to lesson 7.2. We're now going to continue our work with our graphing. Now we're going to take a look at how data can be misinterpreted. Now, what misinterpreted means is that the data appears to be something or presented in a way that is not correct, though it may be true. It may be hard for you to understand that, but let's just get this down and we'll talk about it, okay? So what is misinterpreting data? It is making data appear to be something it is not. Okay? Now, why would this be done? Well, it could be done to mislead a person, and that's basically why, I guess that's the total of it. It's done mislead the viewer. Now, have they lied in terms of what they presented on the paper? The answer to that is most likely, or most cases, no. It hasn't been lied. They haven't done anything wrong. However, they've presented the data in such a way that if the viewer is not careful, they will come to the wrong conclusions. So let's take a look at two of them, for example. This is out of your textbook. This is the average house prices in two places, Victoria and Fraser Valley. Okay, I'm just going to leave it like that. I suppose I should. Okay, house prices in Victoria and Fraser Valley. I guess Fraser Valley has an S. Okay, now at first glance, which graph appears to show the greater difference in house prices? Well, let me look. The big differences are from here to here, here to here. So the one that shows that the greatest difference is graph A. The question to that is why? And it all goes down to here. The graph does not start at 0. They've used a scale break to start the graph at 200,000. Right? And what that does is that spreads the data out this way. It makes it lengthen longer. And because it makes it longer, it makes the differences between them exaggerated. Okay? There are greater differences between the heights of the bars. Okay, so turn the page. Now, is the data graphed different for the actual two? If you take a look at the graph very carefully, you'll notice that it's the same information. So no, it's not different data. Everything is properly, is the graph information is the same. So the question is, if the information is the same, why is it so different? Well, if you look over here, we said that this one here started at 200,000. This one started at 0. If you take a look at a block here, one single block here to here, that's $50,000. You go over here, from here to here, that's $20,000. Okay, so this is a big difference. They've exaggerated the scale by making the scale they put on the graph larger. Okay, so on the graph A, 1 square equals $20,000. And on graph B, the other square is $50,000. Okay, now how are the scales different? I actually have the answer in there by accident. The scale of graph A starts at 230,000. Graph B starts at 0. Okay. So is graph A lying? No, it's not. Even though you may seem to be, they're not lying. It's the viewer responsibility to recognize what is being done. Now, if we go back to the graphs for just a second, you may ask yourself, well, why would people do this? Why would they have two ways of doing the information? Well, let's just say, for example, you wanted to attract people to come to one of these two areas. If you wanted people to come to Fraser Valley, and you know that you're in direct competition with Victoria, so what you want to do is the people who would normally go to Victoria, you want them to come to Fraser Valley. Now, if the house prices appeared to be significantly lower in Fraser Valley, those people who would normally go to Victoria would change and come to Fraser Valley. So that's what this graph here would do. If I wanted to buy a house, right, I would take a look here and see, look, what's happening to the price values? Victoria's prices are going through the roof. So I should be shopping for a place where the prices are significantly lower. So I'm going to go to Fraser Valley. Now, if you wanted to show that there's no real big difference between them, then you'd start at 0. Now, this person probably is doing a comparison of the housing prices as some sort of a gathering of information for, I don't know, for tax purposes or something like that. And they would be comparing things. In this particular graph, graph B, it shows the proper graphing of this in terms of being able to compare because it's all the same scale, and this shows a better representation of the differences. Okay. So let's go on. All right, here we go. Look at the following graph and how it misinterprets data. This one's a great one. It says the ski resort industry is taking off. Winter resort industry takes right off. Now this has got so many things wrong with it. It's kind of interesting because it's kind of like, it's a great example for me to use. For example, let's take a look at some of the stuff right here. Look at this scale here. Squished up and then spreads out. Look at the vertical line, so the horizontal line here. That's horizontal. And then look up here. That one's at a significant angle. Okay? The graph itself goes like this, and because it almost is steeper here than this line is here, it makes it even give an even more of an indication that things are going great. However, if you are smart and you're looking at it and you see these things, you will notice something very unique. The fact is, the ski resort industry has been performing extremely poorly, and it's even to the point where if you're very, very careful, you will see that all the way down here to this point, they've been losing money. Takes off, that's this portion right here. And if you were to graph it, you can see the differences between the numbers here. Here's 100,000, 200,000, 300,000, and so that means that this is the 200,000, and this is 300,000. Right? And you'll notice that down here, they're very close together. Out here, they're spread further apart to exaggerate it. So look where this graph actually goes, okay? Right here. It's kind of hard to tell because of the way the graph is drawn, right? There's a horizontal and a vertical, but this is the graph line right there. So it makes you look at it, and because the guy's ski jumping, he's jumping off, he's higher than the actual graph bar is, it makes you get the impression that, hey, things are going really great in the winter industry. But if you were to graph this properly, and I'm just going to freehand it here, you'd probably see something like this. Now, I don't know if you can look at that, but I look at that and I go, that doesn't exactly give me a lot of confidence that the winter resort industry is going crazy. All right. In fact, if you look at it, the majority of the last from 1987 up to 1992, things have basically been losing money. So, how does the graph misrepresent the data? Well, where do we begin? Okay. Okay. So, how about the grid lines are sloped? Okay, so that's the first thing that's wrong with it. Okay. The x-axis scale is, well, it's really messed up. Spreads out. Okay. What else I got? The skier himself, he gives the impression with his skis. If you notice, the skis are pointed much higher than the ramp is. Okay. What else? I guess that's a good thing to start with. All right. So is the ski resort actually taking off as it says? The answer to this is no. Okay. The best that can be said is that the last year was a slight, and I mean a real slight, improvement. And I'm not even going to swear to that, because looking at the information right in here and how it's drawn, I could actually be wrong there. It could actually be just horizontal or maybe even decreasing, but I get the impression looking at it it's gone up a little bit. All right, let's take a look at this one. Look at the following graph of unemployment rates. Is the annual employment rate increasing? What do you think? And I think it's pretty obvious that it is. It's going up. Right? But there's some big differences here and some really interesting things you can look at. I think most of you are going to pick out the fact that that's sloping upwards. Right? So if I were to take and put a graph, a horizontal line there, you can see that they've got their columns going up significantly. Okay? Now, the other thing that you may not have noticed is, look at the difference between this year, here we are, between this year here and that year there. All right? Notice that that is 0.1%. All right? Now, let's take a look at the last 2 years. Here and here. See if I can get these to slide in a little bit better. Okay, so there's that one, just below the line. There you go. Look at the difference. Now, this is from 11.0 to 12.5. So this is a 1.5% increase. So this here should be 15 times the difference as is from here to here, because this is 0.1, right? So it's really should be significantly different, and it's not. Okay. Now, why they've done this, I don't know. It kind of is weird. If they wanted to show that the unemployment rate was going up like crazy, then they should have had this one here considerably higher. I guess what they're trying to do is keep this slope and this slope relatively the same to show that unemployment rates, I don't know, are going up. It's a seriously messed up graph. I can't see any good out of it. If I was trying to show that the employment rate was going up, I guess I could do it this way, and you can see that things are increasing, aren't they? They're doing great. Right? And I guess that's the only interpretation of this graph. So how does the graph mislead the data? Well, the x-axis is not horizontal. And of course, the vertical scale, the y scale, is not even. Okay? Let's go to some of the easier ones. Grade 8 students have scored math higher than 80% on a math test. How is this data represented? Well, when you first glance at it, area equals amount in most people's heads. So when you look at this, are they trying to say that the boys, they rented a room on the top, so they moved what would have normally been up here down to here? Right? Should have been this way. And they didn't have room, so they moved it down to here? I don't know. But these here should be the same thickness. Okay, so the boys bar is double thickness. And that gives you the impression that the boys are doing better, when in fact, if you look carefully, it's actually the girls who have a higher score. All right, here we go. This is called a pictograph. All right. Notice that one ice cream is equal to 3 students. So we've got chocolate. Let's see, we got 1, 2, 3 is 4 times 3, so this is 12 people. Vanilla is 6 people. And bubblegum is 9 people. You can see that by having different size cones, they've made the bubblegum much longer lineup than these here, than the 12. Okay, so the cones are different sizes. Obviously, this person wants to show that bubblegum is the favorite flavor for whoever they're considering. Favorite music. What's being done in this example? Well, if you take a look, pop, rock, and hip-hop, there's about 11 pop. Everything, the data is all the same. But again, look at the scales here. Okay, the scale from here to here, that's 3. This one here is actually a smaller box, and it's actually equal to 10. So your vertical scale are different. And by doing that, it exaggerates the differences, making it look like pop is significantly more attractive to people than in the other graph. In fact, over in this graph, there is very little difference between pop, rock, and hip-hop. So the person drawing graph A is graphing it, I don't know, properly, or not trying to mislead, but the one on the left-hand side here is obviously trying to show that pop music is much more attractive. In fact, if you look at it, it looks like it's almost, double the difference, which it isn't. Okay, well, actually it is, but the impression is that it is much, much different. Okay, what's happening here? Oh, we have milk has been pulled out. And by separating it, it makes it look larger. All right. If you look at it, milk, when you first glance at it, milk's the favorite drink, when in fact that's not true. In fact, water is number 1, milk is number 2, and juice is number 3, but these two here are relatively close. All right, salary increases are up. So now you should be getting pretty good at this. You should have noticed right off the bat that this one here starts at $33,800. And it's going up by 1 box here is equal to $200. Over here, 1 box is equal to $5,000. A significant difference, isn't it? By changing the scale and making the scale go up by less, the vertical differences are exaggerated, made longer. Are they going up significantly? Well, you can see here that probably not. Though if you look at this one, it looks like they are significantly changing. So, are they the same? It's the same data, but the scales are different, right? I guess I should put down the vertical scale, the Y scale. So you should now be starting to get to the point where you can take a look at the graph and you know what to look at for the pieces to find out if they're trying to mislead you. So for the last one there, the one with the salaries, do they misrepresent the data? Again, you got to be careful. They don't. I guess they would say that they do misrepresent it because the scales are much different. But again, the onus is on the viewer. Okay, so I would say yes in this case because the scales are different. Right? One starts at 0 on the graph. The other one starts at 33,800. So the differences are magnified. Now be careful with the difference between the words misrepresenting and lying. They have graphed the data correctly. There's nothing wrong with their graphing. What the graphing is done all right. The problem is the way they've done it will make the viewer come to a conclusion which is incorrect. Okay, so it's time for your assignment, and we will see you next lesson.